Beneath the green canopy of the Amazon rainforest lies one of Earth's greatest mysteries. This region, dense with biodiversity and isolated by winding rivers, has long been thought to hold the story of a single, unified human migration. That story told us all Native Americans descended from people who crossed a frozen land bridge from Siberia. But what if that's not the whole truth? What if the first Amazonians weren't just the descendants of Beringian hunters, but of a people with ancient roots thousands of miles away? Before we start, I'm on a road to get 1,000 subscribers as a small channel. If you want to help me, please subscribe. The Amazon basin covers more than 2 million square miles across 9 countries, from Brazil to Peru to Colombia, dominated by dense rainforests and vast networks of rivers. Historically, archaeologists believed the region's indigenous populations descended from a single founding migration of people who crossed the Bering Land Bridge from Siberia into the Americas around 15,000 to 20,000 years ago. As these first Americans moved southward, they diversified, adapting to new environments. In this traditional view, all Native American populations, from Arctic hunters to Amazonian fishers, shared this common origin. The people of the Amazon were seen as one branch of this singular migration, shaped over time by isolation and ecology. The Amazon itself, with its humid climate and acidic soils, made archaeological preservation difficult. So, for decades, this model went largely unchallenged. But cracks in this narrative began to emerge, not through artifacts, but through ancient genes. And what those genes revealed was shocking. The first hints that something didn't fit the standard story came not from DNA, but from bones. Early human remains discovered in Brazil, like the famous Luzia woman, exhibited cranial shapes that looked more like indigenous Australians or South Asians than modern Native Americans. Anthropologists debated whether this was simply variation or evidence of a deeper history. Then, in the 2010s, geneticists studying Amazonian groups like the Surui, Caritiana and Xavante uncovered a faint but persistent signal in their DNA, one that seemed to echo that same Australasian connection. These indigenous groups showed more genetic similarity to people from Papua New Guinea and the Andaman Islands than to their closest Native American neighbours. The connection was weak but statistically significant, and it didn't appear in North or Central American populations. Something was different about the people of the Amazon, something ancient, unexpected, and invisible in the archaeological record alone. To investigate these mysterious genetic traces, researchers turned to genome-wide comparisons using sophisticated tools like F-statistics, PCA plots, and admixture modeling. In landmark studies led by teams from Harvard and Uppsala University, scientists analyzed the DNA of dozens of Amazonian individuals and compared them with ancient and modern genomes from around the world. The most striking signal appeared in specific indigenous groups from the Brazilian Amazon. These groups, especially the Surui and Caritiana, showed genetic affinities with Australasian populations, Papua New Guineans, indigenous Australians, and Andaman Islanders. The researchers dubbed this mysterious ancestry population Y, from the Tupi word Yipiquera, meaning ancestor. Importantly, this Australasian affinity wasn't present in northern Native American groups, suggesting a unique story in the Amazon. It pointed to either a separate migration from Asia with deep Australasian ties, or a structured founding population that included both Beringian and ancient Australasian-related ancestries. Either way, the discovery was groundbreaking. The detection of Australasian-like ancestry in the Amazon stunned the scientific community. It wasn't strong, it made up perhaps 2 to 3% of the genomes in these groups, but it was consistent and statistically robust. No other Native American populations carried this signal, not even those in Central or North America. It was as if a ghost population had left a subtle genetic fingerprint in the Amazon and nowhere else. Researchers debated how this population Y ancestry had arrived. One possibility, a previously unknown migration, entered South America early, perhaps before or shortly after the main wave of first Americans, and settled deep in the Amazon, eventually overwhelmed genetically elsewhere but preserved in isolated rainforest communities. Another theory suggests that the founding population in Beringia was already structured, containing diverse ancestries including this Australasian-like branch, and that through random drift it only persisted in some groups. Either way, the Amazon became a genetic time capsule. The discovery of population Y upended the long-held belief in a single uniform founding population for the Americas. Instead of one wave of migration from Beringia, the genetic evidence now points to a more complex peopling process. It's possible that several groups, genetically distinct but all originating from Asia, entered the Americas in waves over thousands of years. Some may have followed the Pacific coast, others inland through the ice-free corridor, and at least one with Australasian ties may have pushed deep into South America. The Amazon, with its geographic isolation and ecological barriers, may have served as a refuge where this genetic legacy endured. This doesn't replace the original model, it adds to it. Most of the ancestry in modern Native Americans still traces back to that first major migration from Siberia. But population Y adds another thread to the story, a reminder that even in prehistory, human journeys were complex, layered, and full of surprises. Despite the genetic evidence, the Amazon's ancient cultural record has not yet clearly revealed the presence of this mysterious lineage. Archaeological layers remain difficult to interpret due to the rainforest's poor preservation conditions. Yet the persistence of population Y ancestry in some communities and not others suggests ancient cultural boundaries, perhaps linguistic, territorial, or spiritual, that kept groups genetically distinct. It's also possible that isolation by rivers and dense forest preserved genetic uniqueness. Over time, intermixing may have diluted this signal across most of South America, but the Amazon, shielded by nature, held on to that ancestral memory just a little longer. While the population Y signal is most evident in genome-wide comparisons, researchers have also examined uniparental markers like mitochondrial DNA and Y chromosomes. These markers provide a narrower but valuable glimpse into maternal and paternal lineages. Most Amazonian groups carry haplogroups commonly found among Native Americans, like mtDNA haplogroups A2, B2, C1, and D1. However, a few rare lineages have surfaced that may reflect deeper or divergent ancestry, though none have yet been conclusively linked to Australasian origins. The absence of strong mtDNA or Y-DNA evidence doesn't negate the population Y signal. It simply underscores how ancient admixture can leave faint yet durable genomic echoes. The genetic signal of population Y compels a fundamental rethinking of Amazonian prehistory. Rather than a one-dimensional migration narrative, the region's early history may have involved a rich mosaic of ancestries converging deep in the rainforest. Some groups may have carried genes from long-lost Asian populations with links to Australasia, populations that disappeared elsewhere but survived in the genetic fabric of Amazonia. This challenges not just the migration model but also how we understand indigenous diversity today. The Amazon's people weren't simply cultural offshoots of northern migrants, they were participants in a much older, more intricate story. They retained rare ancestries lost in other regions, shaped not just by environment but by deep human history. It reframes the Amazon not as a genetic backwater, but as a reservoir of ancient diversity. Ancient DNA doesn't just tell us where people came from. It shows how much complexity has been hidden beneath the canopy all along. The discovery of population Y raises more questions than it answers. Where exactly did this Australasian-like ancestry originate, and when did it arrive in South America? Were there ancient migration routes we've yet to uncover? Could skeletal remains in remote Amazonian sites still carry clearer traces of these early peoples? Scientists are now pushing for more ancient DNA extraction from archaeological remains across the continent, especially in the Amazon. Combining genetic, linguistic, and archaeological data might reveal how widespread this ancestry once was. The forest still holds its secrets, but each new genome brings us one step closer to rewriting the human map. The forests of the Amazon have long been seen as mysterious, but now ancient DNA is revealing a truth even more extraordinary than we imagined. The first Amazonians weren't simply descendants of Siberian wanderers. They may carry echoes of peoples who also gave rise to Australians and Papuans. Hidden deep in the genome, a ghost lineage has whispered its story through time. It reminds us that human history is not a straight line. It's a web, tangled and vast. What other forgotten ancestries lie buried in the genomes of people today? Let me know your thoughts in the comments, and if you want to support this kind of work, consider subscribing.